Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Linear Algebra series and concerns the basics of matrices. This guide gives an introduction to matrix algebra, including how to write and name a matrix, how to perform matrix addition and subtraction, and how to multiply a matrix by a scalar. Introduction. A matrix is something you will often come across in mathematics. They are a very powerful tool in handling large amounts of data, as the mathematical rules for combining and manipulating matrices, which is the plural of matrix, are easily carried out by a computer. In computer graphics, matrices are used to project a three-dimensional model onto a two-dimensional screen, which creates realistic seeming motion. In physics, they are used to simplify complicated calculations in quantum mechanics. In fact, wherever complicated sets of equations need to be solved, matrices are used. A matrix is made up of rows and columns of numbers or symbols, called elements, which are usually arranged within square brackets. The symbol for a matrix is an italic capital letter. This makes them easy to refer to, since writing matrices in full, especially if they are large, is time consuming. For example, this is a matrix. M is a matrix with 2 rows and 3 columns. It has 6 elements: 3, 7, 4, 5, 2, and 0. Matrices come in different shapes and sizes, and you can describe them in terms of their dimensional size. The dimension of a matrix is given by two numbers m and n, and is written as m cross n. This is not m multiplied by n, but is said as m by n. Specifically, m is the number of rows are horizontal, in the matrix, and n is the number of columns are vertical. The size of a matrix equals the number of rows by the number of columns. The matrix M above has 2 rows and 3 columns, and so has a size of 2 by 3. You can say that M is a 2 by 3 matrix. Example: describe the size or dimension of the following matrices. Matrix A equals 2, 3, 7, minus 1. A has 2 rows and 2 columns, and so is a 2 by 2 matrix. B equals 4 minus 3. B has 2 rows and 1 column, and so is a 2 by 1 matrix. C equals 3. C has 1 row and 1 column, and so is a 1 by 1 matrix. D equals 4, 1, minus 3, 8, 9, 3, 0, minus 6, 6, 2, 5, minus 1, 0, minus 2, 3. D has 3 rows and 5 columns, and so is a 3 by 5 matrix. E equals 2, 0, 7, minus 1, 5, 2, 5, minus 4, 3, 2, 6, 1. E has 4 rows and 3 columns, and so is a 4 by 3 matrix. Some special types of matrices. 1. Square matrices. A square matrix has the same number of rows and columns. These are very common types of matrices and form the basis for more advanced studies of matrices. For example, if A equals 2, 3, 7, 1, then A is a 2 by 2 square matrix, and B equals 1, 0, 3, 0, 8, minus 6, minus 1, 7, 2, then B is a 3 by 3 square matrix. 2. Row matrices and column matrices. A row matrix is one that only has one row, but any number of columns, and a column matrix is one that only has one column, but any number of rows. For example, matrix A is a column matrix as it contains one column only. It is a 2 by 1 matrix. Matrix B is a row matrix as it only has one row. It is a 1 by 4 matrix. Row and column matrices are common in many subjects where mathematics is used, as they are often used to represent vectors. 3. Diagonal matrices. An important part of a square matrix is the principal diagonal, which goes from the top left element to the bottom right element. For example, the principal diagonal in the matrix below comprises the elements 1, 8 and 2 and is highlighted below. If all the other elements in a square matrix other than those in the principal diagonal are 0, then the matrix is called a diagonal matrix. For example, by making all the other elements in the matrix above equal to 0, you get the diagonal matrix this. 4. Identity matrices. If all the elements in the principal diagonal of a diagonal matrix are equal to 1, then the square matrix is called an identity matrix. There is an identity matrix for each size of square matrix. An identity matrix is denoted by I subscript n, where the subscript n is the number of rows or columns in the matrix. For example, the identity matrix I2 looks like this. The identity matrix I3 looks like this. The identity matrix I4 looks like this. Identity matrices play an important role in the multiplication of matrices and advanced matrix methods. Adding and subtracting matrices. The most important thing to remember about adding and subtracting matrices is that you can only add and subtract matrices which are the same size. That is, matrices that have the same number of rows and columns as each other. The result of addition and subtraction of matrices is also a matrix of the same size. It is important when you are beginning to understand the basics of matrices whether you can or, as importantly, cannot perform the operation you need. You should also work out what size of matrix you expect your answer to be. This allows you to sketch your answer out, use a matrix of the size you require and section it up into where the elements should go and use it to work out the actual final answer. See below. When you are adding and or subtracting matrices, each element in the result is found by adding or subtracting as required the corresponding elements in the matrices. Take the two matrices A and B. You can calculate A plus B as both A and B are the same size, 2 by 2. The result is also a 2 by 2 matrix whose elements are found as follows. Top left of A plus top left of B equals 2 plus minus 1, which equals 1. Top right of A plus top right of B equals minus 1 plus 4, which equals 3. Bottom left of A plus bottom left of B equals 0 plus 5, which equals 5. Bottom right of A plus bottom right of B equals 3 plus 3, which equals 6. So, A plus B equals 2 minus 1, 0, 3 plus minus 1, 4, 5, 3. You can now make your sketch using dotted lines to break it up into a 2 by 2 matrix, like this. The top left element is 2 plus minus 1. The top right element is minus 1 plus 4. The bottom left element is 0 plus 5. And the bottom right element is 3 plus 3. This gives the result of a plus b equals 1, 3, 5, 6. Example, given that matrix A equals this, matrix B equals this, matrix C equals this, matrix D equals this, find, where possible, 1. A minus B. A minus B is possible as both A and B are 2 by 2 matrices. So, A minus B equals 2 minus 1, 0, 3 minus 1, 4, 5, 3. The answer is going to be a 2 by 2 matrix, so draw a pattern. Top left element will be 2 minus 1. Top right element will be minus 1, minus 4. Bottom left element will be 0, minus 5. Bottom right element will be 3, minus 3. Calculating this gives A minus B equals 3, minus 5, 0. 2. C minus D. C minus D is possible. C minus D is possible as both C and D are 2 by 3 matrices. So, 1 minus 3, 4, 2, 1, 1, minus 0, 1, 1, 5, 2, 3 equals a 2 by 3 matrix, so draw a pattern. Top left will be 1 minus 0. Top middle will be minus 3 minus 1. Top right will be 4 minus 1. Bottom left will be 2 minus 5. Bottom middle will be 1 minus 2. And bottom right will be 1 minus 3. Performing these calculations gives C minus D as 1 minus 4, 3, minus 3, minus 1, minus 2. 3. A plus C. A plus C is not possible as A, a 2 by 2, and C, a 2 by 3, are different sizes. Multiplying a matrix by a scalar. A scalar is a single number. To multiply a matrix by a scalar, you simply multiply every element in the matrix by the scalar. This is very different to matrix multiplication, which is discussed at length in the study guide, Matrix Multiplication. The result of multiplying a matrix by a scalar is a matrix of the same size. Example, given the matrices A equals this, B equals this, and I equals this, find 1, 3A. Throughout these following answers, the dot, this, is used to imply multiplication. 3A equals 3 multiplied by 2, 1, minus 1, 4. The answer will be a 2 by 2 matrix, so draw a pattern. To find the answer, multiply each element in turn by 3. Top left is 3 multiplied by 2. Top right is 3 multiplied by 1. Bottom left is 3 multiplied by minus 1. And bottom right is 3 multiplied by 4. Performing these calculations gives 3A equals 6, 3, minus 3, 12. 2. Minus a half B. Minus a half B equals minus a half multiplied by minus 10, 2, 0, minus 4. The answer will be a 2 by 2 matrix, so draw a pattern, like this. Top left will be minus a half multiplied by minus 10. Top right will be minus a half multiplied by 2. Bottom left will be minus a half multiplied by 0, and bottom right will be minus a half multiplied by minus 4. Performing these calculations gives the answer of minus b of 5, minus 1, 0, 2. 3. Lambda I. Lambda I equals lambda multiplied by 1, 0, 0, 1, which equals a 2 by 2 matrix, so draw a pattern like this. Top left will be lambda multiplied by 1, top right will be 0, bottom left will be 0, bottom left will be 0, and bottom right will be lambda multiplied by 1. After performing these calculations, you find that lambda I equals lambda 0, 0, lambda. Notice that when you multiply this or any identity matrix by any scalar, you get a diagonal matrix. 4. XA minus YB. Again, in this question, X and Y are symbols used to describe any given scalars. XA minus YB equals X multiplied by 2, 1, minus 1, 4, minus Y multiplied by minus 10, 2, 0, minus 4. This means you subtract the following 2 by 2 matrices. Here are the patterns. Let's take the first matrix. Top left is 2 multiplied by X, top right is 1 multiplied by X, bottom left is minus 1 multiplied by X, bottom right is 4 multiplied by X. Now the second matrix. Top left is minus 10 multiplied by Y, top right is 2 multiplied by Y, bottom left is 0 multiplied by Y, and bottom right is minus 4 multiplied by Y. This gives the answer of 2x minus 10y, which is 2x plus 10y, x minus 2y minus x, and 4x minus 4y, which equals 4x plus 4y. Further guidance and information. If you have any further questions about mathematical skills or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.